Thanks for coming, guys. Really appreciate it. We've got about, I'd say, somewhere between. All right, so we'll cover a little bit of policy management and some performance-related data for virtualization as well. This is unified computing, a very fancy word for servers at the end of the day, but there's a good reason why we call it unified computing. We realized a while ago that here at Cisco that doing just the network layer all the way to the access is not enough. Virtualization is really changing that final last jump from the network to the compute. You have to offer both sides of the infrastructure to be able to tie them together in a nice fashion so you can support things like vMotion, you can support things like workload mobility. We've shipped for over a year now. Just fantastic reception in the marketplace. We've got some very loyal, just fantastic customers, great feedback. We've had several technical advisory board with the customers and rolled that feedback already into the product. We're on the second generation of the product today. There's over 1,700 customers as shared by our CEO at the last quarterly pitch. And there's a whole slew of other statistics I put up there as well. But it's a phenomenal reception that we at Cisco have gotten over the past about year and a half or so. And on the performance front, I'll share with you later in the slide deck when we talk about performance, how the infrastructure is really truly geared towards very phenomenal numbers on the performance side. I'll share the numbers on the benchmarking, on the I/O side, on the CPU side as well. For those of you who are not very intimately familiar with UCS, what I've tried to do is instead of carving out maybe 10 minutes of the presentation on a short introduction to UCS, I don't want to waste everybody's time. I'll just share with you just a few high-level thoughts right here. And then as we get to the appropriate sections, I'll highlight a few things if you're not familiar with those. That right there is a typical UCS system. If you're familiar with blade environments, a blade is sort of a data center in a box. It's really just sheet metal. It holds some networking in the back, some compute up the front. That right there is a virtual chassis. Imagine that little chassis, the 10U, 12U, 16U chassis in your environments today. That is the equivalent of that. However, it's a virtual chassis. If we build a chassis that large, or even larger than that, I doubt anybody would buy it because just the chassis itself would cost hundreds of thousands of dollars. And it doesn't make any sense. Very few customers of ours design data centers in that fashion, several racks at a time. So what we did was we designed one logical domain. All the switching is right up there, where you see right up there. So that's all the access layer switching. The management application also resides up there, manages all the blades as one. The chassis is merely a physical form factor. It's like a Lego block. Whether you put a blade in the bottom right chassis or you put a blade in the top right chassis, it really doesn't matter from a system perspective. All the data plane connections, all the management constructs, they're all available to every single server in the system. That single point of management up top is what we call UCS Manager. And as we go through the presentation, you'll see how two aspects come together to offer some of the benefits I'll talk about. One aspect is the fact that UCS Manager has full insight into not just the compute that it's managing, but also the access layer connectivity to that compute. And then the second aspect that's really important is the fact that all data plane connections are the same, whether you're talking from between two VMs on the same blade, or two blades in the same chassis, or two blades in two different chassis. All the data plane connections flow in a very consistent manner. So applying policy is very, very simple in that environment, be it physical or virtual. All right, so let's dig right in. Here's about a few weeks ago when we started thinking about, what do we want to talk about at this VMworld? We could talk about UCS. We could give you an introduction to what is UCS and share, how great our customers think it is, and that's all great. But I came across this survey that was done earlier this year, and it was very clear that what the survey was pointing out is very consistent with my conversations with our customers too. Look at those top two, performance and manageability. This is today. And the question was very simple. The question was, what are your top concerns? Virtual infrastructure, what are your top concerns? And the questions make total sense if you think about it. In the phase that we are today, for a large subsection of the applications, the top-of-mind question is, when I virtualize this, what's going to be the performance benefit? Is it going to work really the way it used to work in a physical environment? What am I giving up? Surely there's a cost to this thing in terms of performance. So that's top of mind today. And then as you progress in pretty much any technological cycle, once you've convinced yourself that the performance is taken care of, it's going to work as desired, you notice that then the next concern becomes manageability. Because, okay, I've decided to deploy this thing. I'm pretty comfortable that it's going to perform okay. Am I going to be able to manage it at scale? And those two are consistently the top two concerns. Any technology, by far. Most technologies I've seen in the data center, performance and management are the top two concerns. So those are the ones I'm going to dig in deep on today. There's a whole host of other concerns too, but really the ones that we will be focusing on today are manageability and then the performance of the infrastructure. All right, let's start with manageability. There's nothing unique about management, at least at a 10,000-foot level, that virtualization brings fresh to the table. In the sense, the challenges are always the same, right? If you're managing two elements in your data center, back when I was in school as an intern, if I'm managing two servers, who cares? You can manage it in 100 different ways, and none of our they're all equally efficient or inefficient. It really doesn't matter. Management at scale is the challenge. And there are data centers out there which might not be virtualized, but they still have to manage 1,000 servers, 10,000 servers. And so these manageability and management concerns at scale are true, be it physical or virtual. There's a couple of things within in unified computing which are core to how we solve the manageability issue or managing at scale. Here's what makes management a slight issue. Let's say, at a higher level, let's think about how deployment really works, right, in a standard environment. Your application admin comes up to us as infrastructure admin and says, I want to deploy Oracle, or I want to deploy ESX, or what have you. And my requirements are, my best practice says, I need 6 Ethernet interfaces, a couple of fiber channel interfaces, I need this type of CPU, memory, hard drives, and so on. Please go buy this infrastructure for me. And, we are all good infrastructure admins. We go out there, we buy, we plunk it down in a rack, and then the next rack. And then some other application comes out, and that goes in the next 2 racks, and so on. Fast forward that 6 months down the line, and what you have is essentially an infrastructure where you can't move workloads if you really wanted to, because you're tied to what you bought for that. The rack next to it might not have the same network connectivity that the workload needs, so you really can't move it. And the reason for that is there's all the state built in. Purchase time state, because you decided how many interfaces that particular infrastructure is going to have. And of course, deployment time state. You might have decided that this particular application works with this revision of BIOS with this setting. Some applications are that sensitive, right? Databases are a classic example. So what happens when you want to move, kill that server or replace that server? You're going to have to go into the BIOS and redo the settings and make sure everything is as the application admin expects and demands. That's not scalable. If you keep doing that day after day, then that's the kind of drudge work that we as infrastructure admins, come to dislike. And at scale, across 100 servers or 1,000 servers, it's completely useless to even try and do it because it's impossible. So here's what we did. We took all that state that's traditionally sitting down in hardware, from UUIDs, simple things like UUIDs and MAC addresses, to somewhat complex things like how many Ethernet interfaces do you have? How many fiber channel interfaces do you have? What's the firmware setting on the mezzanine card or the NIC that you're using on the server? All that thing that gives the server state, we abstracted it out and put it in a real simple file. It's literally an XML file. You open it up and you'll see just XML in there. UUID equals this, and please give me 6 Ethernet interfaces. Here are the MAC addresses. Here are the VLAN, so on and so forth. So we took all that state, and the advantage there is now you can abstract it out, put it in a software file, and what you've done is what the application admin cares about, that's now sitting in a software file. So now going back to my example, when you want to move that Oracle or that ESX or whatever that workload might be running and you want to move it across the data center, it's really easy because you're not moving the actual physical blade. All that you're moving is that service profile, that XML API that gives that server a particular state, from MAC addresses to UUIDs to a bunch of other stuff, including BIOS and BIOS settings. Hyperthreading. How often have you had to go down and turn hyperthreading on or off because different application admins want it on or off? And addressing those within a software construct like this is the only way to scale. So that's one thing that we did. The other thing that we did was, getting back to my original example, we tend to tie down, from a network perspective, we tie down individual blades at the end of the network. Think about it. Our data centers are essentially a big network, and at those endpoints, we tie down servers. And how we tie down is pretty interesting. Sometimes we tie them down with 2 Ethernet interfaces, sometimes with 6 Ethernet interfaces, and a couple of fiber channel interfaces, and so on. But by the act of doing that, what you've essentially done is only that workload, which demands that sort of I/O, is going to run out there. But what's really critical, the application admin doesn't care whether you put in 4 NICs or 5 NICs. At the end of the day, what the application admin should care about is how much bandwidth do I need in aggregate for management, for LAN, for SAN, coming out of this box. And if you could design your infrastructure to that, that's attractive. And that's what we did with UCS as well. So in UCS, for instance, the question is not, am I going to run workload A or B or C, and does it need SAN connectivity or not, or how much LAN connectivity does it need? The question is, how much aggregate bandwidth do I need to provide to this particular chassis here? And I might start with something like what I showed on the left, with just 20 gig, 2 10 gig cables going down, and then build up as the aggregate bandwidth need goes up. That's significant, and that's significant because, as I'm sure you're all aware, once you run out of capacity on a particular physical infrastructure, even for ESX, and you want to add a new host to that cluster, it can be quite a scramble if you're running around in the data center trying to figure out which server has access to the back-end networks and has access to the back-end SAN and to the appropriate pieces of SAN so that I can add it to the cluster. An environment like this makes that moot, because the very next server, as long as it has enough bandwidth, can meet the needs of that cluster, and you can add it to the cluster. And then the third thing we did was we changed the management model. We just turned it around. Traditional management model in data centers are somewhat archaic, right? I just showed an example rack here. But in that simple rack, if you put in 2 or 3 blade chassis and you start counting the number of IP addresses, real simple exercise, just start counting off the number of IP addresses you have in your environment in a single rack to manage the chassis, probably a couple of management modules, all the switching on the back, each individual blade, then of course the access layer elements on the networking side. This is not management at scale. So what we did differently was, because we are architected in a way that the central nervous system becomes that access layer element, what we call the fabric interconnect, and the management application sits right on top. It's a single endpoint. It has 100% visibility, a single IP address to manage potentially multiple racks worth of equipment. So those are the 3 things we did slightly differently from the traditional blade infrastructure. At the end of the day, these are standard x86 blades. You know, there's nothing super fancy going on the motherboards here. There's standard CPUs and I/O and memory. But how we architected it to manage it is what's considerably different. So let's see how this helps in a virtual environment. This is sort of my pet theme, which is our ability in UCS to unify your virtual and physical estates. This is critical, right? Today, in any data center, there's a combination of 2. There's physical workloads, there's virtual workloads, and the way they're managed is considerably different. And I'll show you from a network perspective how that came to be and what are we doing differently here at Cisco that our customers take advantage of today. So this is a traditional deployment from a networking perspective, very traditional deployment. You've got the VMs up top sitting on a server, and you've got a vSwitch right in the middle. And you need the vSwitch because, as I show on the right side, the green VM might be talking to the blue VM, and somebody needs to switch that. You can't send it out to the network because it can't come back because of rules of Ethernet. So that's why you need that internal vSwitch. What's the issue? The issue is that becomes an additional management entity that you have to manage. You have to manage policies across. You have to apply the same sets of ACLs and QoS and VLAN trunking and all sorts of other goodness that we don't necessarily get paid extra to do. Just because the mandate for virtualization comes down doesn't mean you're going to get, as network admins especially, or server admins, additional dollars to manage that internal infrastructure. So what do you do? Let's think about this for a second. Why does that soft switch exist in there? I made a statement. It's for internal switching between the 2 VMs on the right. Makes sense. But what if, for those 4 VMs, I actually gave you 4 NICs in that physical server? If you had 10 VMs in a server, standard rack mount, you had 10 VMs in the server, I gave you 10 NICs. Would you still need that internal vSwitch? Think about it. You wouldn't, right? You wouldn't. Because each VM could be sending traffic out on their own network interface, which goes out to your standard physical layer, be it an end-of-row switch or a top-of-rack switch, which switches the traffic between the 2 VMs, be they on the same physical server or across physical servers. So it's that lack of I/O inside the server that creates a problem. And to solve the problem, you need internal vSwitches. So how can we do this differently? Just like I said, if you have 4 VMs and you had 4 NICs in there, then you'd be able to just tie each VM to each one of those NICs. You wouldn't need an internal vSwitch. You wouldn't need to manage it. You wouldn't have to configure port groups and DVSs or vSwitches in vCenter. You wouldn't have to worry about which VLAN goes where, and did I apply the right policies, and did I turn on port security, and did I turn on the right level of QoS? It's a very attractive proposition when I say that suddenly you can manage your physical infrastructure the same way as your virtual infrastructure, because essentially you've taken out that additional complexity from the hypervisor, and the hypervisor goes back to doing what it does best, right? Which is carving out that physical infrastructure for use by individual VMs and not necessarily trying to switch packets on the side. And how does that happen? That happens, to make this happen, I sort of grossed over a very, very big detail, which is the question here becomes, okay, that makes sense, but that doesn't mean, if I have 20 VMs on my server, are you suggesting, Guru, that we're going to put 20 cards in every single server here? Well, that's kind of silly. So this is the difference between current infrastructures based on non-UCS environments and what UCS does. You see that those 4 cards down there? You can't quite see the graphics, but it doesn't say NIC. It actually says vNIC. And there's a good reason for that. This piece of hardware that we designed internally, it's a very simple MES card. It's a really simple technology to understand. It's a single physical card, and all that you do is you as an administrator tell the card, please create 10 Ethernet interfaces and maybe 4 fiber channel interfaces and expose those to the host. Okay? That's all you say. Internally, the card creates 10 PCI devices of type Ethernet and a couple of PCI devices or 4 PCI devices of type fiber channel. So when the host operating system comes up, not just ESX, it could be Red Hat, could be any physical environment, right? But when that ESX host comes up and it scans the PCI bus on the motherboard, what it sees is 10 individual devices of type Ethernet, literally as if you went in and you plugged in 10 Ethernet interfaces and 4 or 5 fiber channel interfaces. From a host perspective, from the operating system perspective, from the hypervisor perspective, it doesn't know that there's a single physical device on the other end. This is not SRIOV, by the way. SRIOV is a similar technology, but it does require host operating system support, because there you have a single PCI device and you've got functions hanging off the end. But this is different. This is literally, unless you actually take that server out and look at the fact that there's only one card in there, you wouldn't know. You could log into Linux and do LSPCI and you'd see 10 devices, right? So that's how. On the going outwards, it's got 2 10 gig interfaces, so it's a 20 gig card, pretty much more than enough to meet any virtualization needs, most virtualization needs that I come across anyway. So how is it managed? Through the same UCS Manager interface that you manage the rest of the infrastructure with. This is just a screenshot. The reason why I pointed out it is within UCS Manager, there's a bunch of tabs. There's a tab out here to the left for servers. There's a tab for LAN. There's a tab for SAN. There's an additional tab for your virtualization infrastructure as well. And there's a good reason for that. This tab is structured in a very simple fashion. There's only 3 larger things on the tab. At the top is some infrastructure for you to say, hey, there's vCenter. This is how you talk to vCenter. Some security credentials, one-time setup. Somewhere in the middle are port profiles that you create. And we'll dig into that a little bit on the next slide. And right at the bottom comes the visibility portion. Remember, the premise I'm starting off with is I'm going to solve your visibility issues and manageability issues for virtual infrastructures from a network perspective. That's where all the visibility comes from. Right at the very end there, all the VMs that are running inside that UCS system, you can look at each vNIC. You can look at each physical server and say, how many VMs are running? Okay, these 4 VMs are running. They've got each 2 vNICs each. Here are the counters for the vNIC. Here are the VLANs that the vNICs are in. And you could have a Red Hat server on the right side, and you could have 4 interfaces going into the Red Hat server, and you'd see the exact same things, the counters, the VLANs, all the networking properties that we've come to know and love, right? So from a network admin's perspective, imagine how attractive this is. I log into a single application. I don't care whether the workload is running virtualized or not. I get the same visibility and configuration that I've come to know and expect in a physical environment for that virtual environment as well. Let me show you a little bit more detail here. You see that port profile out there? Look familiar? It looks a little bit like what you call port groups in vCenter. It's got your standard stuff. You can configure VLANs. You can configure QS policies. If you dig into the QS policies, for instance, you could argue you can configure some things like, hey, this port profile, please restrict all traffic to 10 meg, or 2 gig, or 2.5 gig, or whatever, based on or put it in a certain system class, no drop system class. I don't know, based on your requirements, and a bunch of other stuff too. So, what's new here? Here's what's new. Here's what's going on today. When you decide, from an I/O perspective, you deploy Red Hat, standard physical bare metal server. You go to the switch, and you configure the VLAN, and you configure a bunch of stuff, because you know exactly how it's connected. When you deploy vCenter or a virtual environment, then sometimes the network admin, but oftentimes the server admin, the virtualization admin, has to understand the concept of a vSwitch, define port groups on the other side, which then get consumed by the VMs. And the networking admin is just basically trunking every VLAN in the world down to the physical servers, which, frankly, if you ask me, is downright scary. Why use VLANs if you're going to trunk every VLAN everywhere, right? That, by the way, is not what happens in UCS, as you might imagine. So this is the new operational model. I went into UCSM for this example, and I created 4 port groups, my green, red, yellow, and blue port profiles. And that green could be in VLAN 5, VLAN 10, VLAN 15, VLAN 20. They could have QS and other policies attached to them and so on. And then I hit a button. Remember that VM tab? That's on the VM tab is where I created those profiles. I hit a button. It gets exported all the way out to vCenter, shows up as port groups. And then when the virtualization admin or the server admin comes in and starts deploying the VMs, they become the consumers of those port groups. And as they consume those port groups, those VMs start getting deployed on that UCS infrastructure. So what happens? When that VM goes up, all it knows is that I'm going to ask for network service green. That's it. It comes up and it says, I'm green. And it talks to that adapter, the virtual interface card we talked about, and the virtual interface card says, okay, you need an interface. Here's an interface. And it talks to UCS Manager and says, what the hell is green? And UCS Manager goes, oh, it means it's in VLAN 5, and here's the level of QS you want to apply, and so on and so forth. And it goes ahead and provisions all of that. You didn't have to touch any soft switch. You didn't have to touch any access layer ports. You didn't have to do anything. You've already defined the policies up front, day one, when you were trying to figure out what you're going to virtualize in your infrastructure. This is how you maintain scalability. Any element-based management, if you're managing things element by element, every time a VM comes up or a new server comes up, if your admins are having to touch the hardware, you're toast. There is no way that infrastructure is scaling. And this is how that infrastructure scales, because it's based on policies. So the rest of the VMs come up and so on. And then the beauty of the entire system is when those 3 VMs decide to move, the exact same thing that happened the first time happens again. On that new server, the VM comes up. That VM on the left, for instance, says, I'm red. Please give me network service red. And goes down, talks to Vic. Vic forms off an interface to itself, which is its own interface, fully isolated, both from a QoS and security perspective. And that's it. That's how simple it is. That's the way to deploy a virtual infrastructure that scales, right? The right way is not to take every VLAN in your system and trunk it down to every single server. The right way is to do it in a fashion so that both physical and virtual infrastructures are maintained in the exact same fashion. And talk about visibility in this environment. Everything. The vNICs out here, that green, you've got individual counters and policies and everything that you can attach to that vNIC is fully visible down here. And whether it's virtual or not, it could be like I said, a Red Hat interface, ETH0 in Red Hat, and you'd have the same access. Oh, and by the way, in this sort of an environment, actually, you know what? I'm going to hold off on that till we get to the performance section. I thought we'd have more time, so we'd discuss at least one real customer who's using it in this environment, but I'm going to skip right through. But this is a very interesting customer, at least from my perspective, because a lot of people talk about vMotion across data centers and doing them in a fashion so that you don't have to touch anything. This customer is doing that today. 2 UCS systems in 2 separate data centers, port profiles defined in the exact same way in the 2 UCS systems. So remember my example? This VM goes from here, lands up at the other data center, and says, I'm red. It doesn't care what red means. It just says, I'm red. Give me service red. And the network just provisions itself to give it service red. So some pretty interesting stuff that our customers are doing. Okay. A good management system is in some sense a very open system. It exposes itself to every automation tool that you might want to write in your environment. And that's the reason why I put this in here. Remember I talked about those fabric interconnects, which sort of become the heart and soul of the system? They're running UCS Manager, which essentially exposes an XML API. When we write our code, when we add a feature, we essentially just think in XML API. The GUI, the CLI, everything is a representative implementation of what you could do on top of that XML API. And that's important. Every single thing we do in the system is exposed through those API. It's important for a very simple reason. Like I said, if you want to scale, you have to automate, right? And we have, like I mentioned in the first slide, dozens of ISVs right now who are writing to the XML API. There's a whole Cisco Developer Network with blogs and forums and all sorts of good stuff. I put in some screenshots of somebody who wrote an iPhone application for UCS. And imagine, you could be sitting here and, well, actually, you probably don't want to be alerted. but well, maybe you do want to get alerted if something's going wrong. But this guy, look at that. He's got a really nice screenshot here of the actual machine, the faults, and he can turn servers on and off from his iPhone. And again, that I would lose sleep over it, but it's an example of what you could do, right? I'm exposing the entire management database through that XML API. An XML API is I couldn't write to it. I'm not an engineer, but a lot of other people tell me that it's relatively easy to write to. Here's something we did a few days ago. We worked with a partner of ours. I'll tell you who on the next slide. But this was the UCS system. Pay attention to, that's a physical tab, equipment tag. There's chassis 1 and chassis 2. Hard to read, but right there, that's chassis 1, that's chassis 2. I think of this as the service provider login, if you're in a multi-tenant environment, which most enterprises are now, even without realizing it, right? We're all multi-tenant. So I've got 2 chassis in this example, and the service provider, the actual admin, service provider admin logs in, he sees both of them. Okay, so next step. We went to a really good partner of ours, HyTrust. How many people are familiar with HyTrust and their products? Show of hands. They won Best of VMware last year. So clearly we need to do they need to do a better job at marketing themselves. We've got their CTO right here. She's a phenomenal person. I went up to her a few weeks ago and I said, I want to show folks, can you throw together a really nice demo for me? And I can do a video here, but it's in their booth downstairs, and they're also doing a theater session. But here's what they did. This is the HyTrust policy console, right? And in that console, you can see both of those chassis. So all that they did was they wrote to the XML API, pulled up the entire schema, and now they're visible as to what objects are available in that schema. So now they're sitting between the client and UCS Manager and intercepting those XML API, right? So here's what they did. They defined 2 user groups. In their case, I think Intel and AMD. Okay, so when customer A, that Intel admin logs in, they see just chassis 1. Remember there was 2 chassis here? The other one just disappeared? And when the other one logs in, they see just chassis 2. This is a few weeks worth of work. And they're very hardworking folks. They work very long hours. But still, I'm showing you the power of the system. This is the client sitting on my laptop, and then the client is just a GUI. It executes XML API on the back end, and they're just intercepting the XML API. And when I say, show me all inventory, they just show me chassis 1 as it comes back and just cleave off the rest of the object tree for chassis 2 and whatever's in chassis 2. So some pretty interesting stuff that you can do when the system is just natively visible to you, and it provides visibility not just into the physical environment, but into the virtual environment as well. You can apply that same principle all the way down to the virtual vNICs inside of VMs. So imagine the power of that system, right? You can do some pretty interesting stuff. Okay, so real quick on performance, which is again the top concern, top of mind today. Performance is very simple, right? It's very simple or very complex. It's simple because there's only three things that contribute to performance. There's I/O, there's CPU, and there's memory. Literally, those are one of the 3 bottlenecks. But ensuring that you've got a balanced system is more of an art than a science. You have to carefully, when you're hitting this one, you increase the I/O a little bit, maybe then you'll hit memory and so on. So let me just quickly outline a few different things that we did when we were designing UCS on all 3 of these. Let's talk about I/O real quick. So on the I/O side, we introduced an umbrella term called vNIC a couple of years ago. I'll speak a little bit to that. But essentially, every server within a unified computing system is 10 gig attached. So you've got more than enough I/O for your virtualized environments, at least today, easily. I showed this and I glossed over this earlier. Remember that port profile when you created it? Notice that. It says high performance right there. So I didn't talk about this earlier, but I'll show you what this means. So when you were creating those red, blue, green port profiles in the new operational methodology, you could have clicked on that one. So what does that really mean? Today, vNIC works in two very simple ways. You could create, let's say you've got 20 VMs. I've shown just two. If I showed 20, nothing would be visible. But let's say you've got 20 VMs, and you created 20 vNICs on the virtual interface card. You could expose those 20 vNICs through the hypervisor all the way to the VMs. And you get all the advantages that we just spoke about, right? Full visibility, counters, all management, no internal soft switching that you have to worry about or configure, nothing. That's what we've spoken about so far. There's an additional mode that you can work in. You can work around the hypervisor. It's what VMware calls vMdirectPath. And from a technical perspective, it's a really simple concept. The VM has full insight into every single vNIC. From the VM's perspective, it's got a dedicated vNIC that it controls. It's doing all its DMA transfers directly down to the vNIC. There's no internal hypervisor. Traditionally, you're sending that packet to the hypervisor, to a soft switch, which then might have to copy it or not, and then it sends it down to the actual ETH0, ETH1, or whatever the interface might be. None of that here. You've got a dedicated resource that you can play with. Here's the big advantage. Guess what the CPU is doing? The hypervisor, guess what the CPU is doing in this transaction? Nothing. In a high-performance I/O environment, ever tried virtualizing a very high-performance I/O environment? What happens to the CPU consumption? It goes through the roof. Okay? You could be consuming maybe 20 or 30% of the CPU, just doing I/O. So what happens here? Imagine if you're a service provider or tight on resources, which all IT infrastructures are. You just freed up a bunch of your CPU to be able to do maybe more dense VMs. So several advantages here, right? So here's what happens in this sort of an environment. This is an example test that we ran just a few days ago, I think late last week. I've got a very simple VM right here, which is running in the vMdirectPath mode. It's generating 10 gig. In retrospect, I realized I should have put the CPU consumption here as well, but it's literally negligible because, again, you're working around the hypervisor, right? What CPU is getting consumed in this I/O is the one that the VM itself is consuming to generate 10 gig of I/O. Of course, that's not free. But the hypervisor itself is not consuming additional CPU resources. So what happens? What happens is that this is vMotion capable, by the way. So you're working in that mode, and when you want to do vMotion, it switches from vMdirectPath back to the emulated mode, does the vMotion, comes off to the other side, and goes back into the vMdirectPath mode. And that's exactly what you see on the other side. From inside that VM, it's an 8 gig VM, I'm doing a UDP stream from inside that VM running at 10 gig. So you see when I'm vMdirectPath, I'm all the way up here. I come down as the vMotion progresses, and I fall out of that and go into emulated mode. I do my vMotion, I come up the other side, I'm doing 10 gig again. Why is this important? Because our CIOs are telling us, go virtualize 100%. Well, that's easier said than done. The next time you go and talk to the application admin goes, I cannot virtualize that thing over there because it requires really high I/O performance. This takes that question off the table, right? You might not even be interested in vMotion. You might want to say, I'm going to run just this one application on one server, no consolidation, but I'm only doing virtualization for abstraction purposes, so I can replace the hardware easily or take it down for maintenance when I need to. You're not taking a hit on the I/O side with technologies like this. This is today, right? This is not a grand vision I'm trying to paint for 2 years from now. These are some numbers very similar to what we ran at VMworld last year, but essentially 24 VMs on 2 separate dates across 2 separate chassis doing large file transfer, okay? Bidirectional. So why is this interesting? I'll tell you why, right here. Look at that. The gold is with vMdirectPath. That's vNIC and hardware is the gold, right? And this is the aggregate network throughput. Watch what happens. When the VM density is really low, our friends at VMworld have done a fantastic job at optimizing the network I/O through that system. Fantastic job. Unfortunately, what happens is that as you start scaling up, it's hard to maintain the same level of bandwidth. But if you're working in a vMdirectPath mode, the hypervisor is not even involved, right? So imagine what that aggregate network throughput just keeps increasing as the VM pairs keep going up from 8 to 16, I believe, and then 24. And on the other side is the time to complete that task, which, again, starts coming down as the number of VMs goes up. So it's some pretty interesting data. We've got, what I'll try and do is, after the presentation, I'll ask if I can upload the spreadsheet for the numbers that we ran as well, and you're welcome to go through that and peruse it to no end. But again, that's VMdirectPath, and that's what Cisco is doing in conjunction with VMware, right? This is not just a Cisco developed technology. The virtual interface card really helps, and we've, of course, closely worked with our friends at VMware to make sure that VMdirectPath is part of the hypervisor and so on. So what's the other component? CPU. We all use the same CPUs as server vendors. Remember, I come from the UCS team, so we use Intel processors. All OEMs use the same processors. Nothing there. The difference is, look at how the processors have progressed over the last few years. It's pretty phenomenal. Just in the last since 2009, that VMmark score has almost tripled, both on 2-socket and 4-socket. It's pretty phenomenal. The processors are really, really, they're written from scratch. Our technology is built into the processors today to make sure there's no hit, whether you're running in a virtual environment or not. Things like page tables and memory transitions, all of that good stuff that hypervisors used to do in the old days, it's all gone, right? It's all happening in hardware. And that's why those numbers are going through the roof. The red dots mark Cisco's records. So when on the 2 sockets, we've held the record. On the 4-socket, we held the record when we came out. And again, we released some numbers pretty recently, which again hold the record. Again, nobody buys servers because you were at the top of the benchmark. That's not the point of the exercise. The point of the exercise is to show you the quality and the attention that we're paying to the servers as we design them. And little things matter, believe it or not. It's how hot is the server running? How did you design your cooling for the system? If the system is running a little bit hotter, the performance comes down just a little bit, and that 0.1% difference might be enough to put you second on the benchmark rather than first. But again, just more of an academic exercise personally, if you ask me. Okay, and the last thing on that building a balanced platform or performance scale is the memory, right? 9 times out of 10, we were asking our customers, are you running out of I/O or CPU or memory? What's driving you for your virtual infrastructure to go to that second server and the third server and the fourth server in that cluster? And 9 times out of 10, it was memory. And I'm curious if you've had a similar experience too. How many people would agree with that statement that more often than not, it's the memory that becomes a constraint? That's interesting. That's a pretty high number. Especially when you start looking at things like VDI. Memory is invariably the first thing you're going to run out of because you're not really consuming too much CPU or I/O in those situations. So what we did there was a technology we introduced last year called memory expansion. And the reason was pretty simple. We asked some of our customers, what are you using for your virtual environments? At the time, they were using 4-socket servers. And personally, I was somewhat surprised because 4-socket is a pretty beefy server to use for virtualized environments. And the reason why they were using it because they needed a lot of memory. They were running out of memory. So what we did was on a single 2-socket Westmere-based system, we can attach up to 48 DIMM slots. And these are DIMM slots. This is not special custom memory that Cisco built. This is just extra DIMM slots on the motherboard. Populate them with 8 gig DIMMs, and you've got 384 gig of memory sitting on a 2-socket board. I doubt you'll run out of memory in those environments. Although I've been proven wrong in the past on things like those. You can never have enough memory. So this is where we started. We talked about manageability and performance being the 2 big things that I was going to focus on today. And if there's one thing that you could walk away from, this is it. On the management side, what I've shown you is what our customers are using today, how from the I/O side, they're managing both the physical and virtual in the exact same way. And on the performance side, they've come to expect bare metal performance out of those servers today, right? That's really my pitch. I'm open to questions, but that's what UCS is about. From an I/O perspective, it's about taking those I/O-related questions off the table. Next time you walk up to your application admin and the application admin throws the I/O thing in your face, we've got a solution for you. Come talk to us. We'd love to talk to you more. And of course, my little sentence down there, the scale of virtualization with the manageability and performance of physical environments. How do you like it? Okay, not so much. So maybe I'll take it off. I think that's it, and I'm spot on time, right at 45 minutes. Open to questions, and of course I'll be here too. We've got some of the engineers who worked on things like VMdirectPath and the emulated mode are all right here. So you want deep technical questions, this is the time to ask them. And I again thank you for your time. One by one, Arthi, been a long time.
I had a question on the manageability section.
Sure.
1000V versus the management operational model that we saw today,
right.
When would I go with one versus the other?
It's a really good question, and it's a question of what problem you're trying to solve. If the problem you're trying to solve is that you want to extend a Nexus-based management infrastructure all the way down to the host, then the 1000V is the perfect product for that. Not only that, the set of features that it brings you is very, very rich. Things like NetFlow. There's only two ways to solve that manageability problem, right? You either take what you're familiar with, Nexus in this case, and you push it into the server, which is that approach. It brings you a lot of features, a lot of goodness. The other approach is you take that networking out of the hypervisor and bring it back to the physical layer. But then, as you know, on the physical layer, you're restricted by the set of features that the ASICs on the physical layer provide. So higher performance, no doubt about it. But if you want NetFlow, then that's a product for you. And that applies largely to features as well. So the question really for our customers is, what is the first order problem I'm trying to solve? And it sort of depends on that. We've got, I don't have the splits right now, but we've got probably a fairly good even split between customers who go the 1000V way, and they tend to be very savvy customers who want things like NetFlow and for metering purposes maybe, or things like RSPAN and others. And we've got a whole set of other customers who are so short on resources, just the idea of managing anything additional in their environment is just anemic to them. There's no way they would do that. So their preferred approach is, let me just pull everything back and I'll manage everything from my physical infrastructures just like I do today. Understood?
So just as an add-on, follow-up.
Yeah.
So with the world moving towards the cloud and we're all talking about end-to-end automated management systems, does it really matter whether the switch is virtual, whether it's in hardware, and how does it matter? So long as you can provision it the same way, does it really matter?
If I was the vision and strategy guy, I'd get paid bigger dollars than I do right now. But I'm more of a person of solving today's problems with today's tools, right? You're right. The world is moving to cloud. I don't know what the right approach in the cloud is. Well, I have my opinions, but you probably don't care for those. What I'm telling you right now is you've got problems in data center today. And I've got customers today who are using my technologies to solve those problems, right? That's today. Virtual clouds and, full, flat, wide open networks and playgrounds. Maybe one day we'll get there. Probably not in the next 12 months for sure. And I doubt your CIO is going to say, oh, I like that vision. Let's just wait a couple of years and then we'll implement that. No, the problems are today, right? And this solves that problem today. Yeah, fantastic, isn't it? That's a good vision. I like it too. There was a question on the left side.
So my line of question was along that of if we take the switching decisions out of the hypervisor layer, the next part of that story is then the hardware. Could you speak to fabric extenders, fabric interconnects, the Nexus 7K? Because one of the barriers for us right now, we're a catalyst-based infrastructure. We've got 3750E, 6509s, things like that. How do we get from where we are with that and really fully leverage that without, huge replace of our Ethernet?
Yeah, that's a very common question. Nothing can be a greenfield deployment. The greenfield deployments, at least in my experience, are mythical beasts which don't really exist in person. So, very targeted question, and I'll answer it in a very targeted fashion. Your current infrastructure is Cat 6Ks and 3750s. 3750 was one of my products a long time ago. Fantastic product. Okay, where was I? Right. So the links coming out of those fabric interconnects are standard 10 gig or 1 gig links. They fit into any infrastructure. Nothing in this slide deck today, nothing that I've showed requires anything outside of that UCS system to change. Whatever you have in your data center today, you could have 1 gig, 10 gig upstream. You could have 1 gig fiber channel, 4 gig fiber channel, 8 gig fiber channel. I don't really care. I can fit that into pretty much anything that's out there. So it can be a very step-by-step approach, and typically UCS is a server purchase. It's not necessarily a networking purchase, and that's why it's important to us that we don't tie the two together necessarily today. Because as a purchase, what CI is going to say, yeah, let's rip out the data center and replace both networking and servers at the same time. How exciting. Not going to happen.
Yeah, folks keep coming with these Nexus 7010s in there.
The Nexus is a fantastic product, right? And don't get me wrong on that. I'm just saying that there is no assumption in our product designs that two products have to go into the data center at the same time. And it's a very sort of just gradually build up to the eventual vision. It is important to know where you're headed, right? So what I'd suggest is work together with the Cisco team and say, okay, 2 years down the line, if I buy all these products that you're suggesting I do, where am I going to be? And then just sequence the products and lay them out as probably with your build schedules. Servers tend to be the easier part, right? You're typically, depending on the size of the customer, you're typically laying out a rack every once in a while anyway. So any other questions burning top of mind? Yeah. Port profiles. That's really what it is. We don't try. vCenter, fantastic product. We expect that to be the center for your virtual infrastructure management, right? What the issue we're trying to solve here is that we're trying to avoid network admins having to get vCenter savvy and using two different systems to define their policies. And that's what creates problem, right? Like I said, at small scales, everything is possible. You don't need anything. You just need IPMI. And you log into every circle and server and just set things yourself. Well, who cares? But it's at larger scales that it's really important for us as Cisco to start thinking through how do you do things differently. And the answer to the customer can't be, why don't you get your network admin and send them to a vCenter class so they can deploy port groups there, and then probably have a backend spreadsheet to figure out what port group has what properties and how it ties to my physical infrastructure. That's not how I would do it, right? We have, this is probably not the best forum for that, but we do see the management infrastructure evolving into even more policy-based infrastructure across several UCS systems, talking to one or potentially more vCenters too. And it's going to be a very symbiotic approach. And I think over the next year or two, some of that stuff Ed's going to share in his keynote, I think on Tuesday or Wednesday, Joe? Tuesday, tomorrow. And then over the next 1 or 2 years, you'd see that vision evolve too. But there is certainly going to be more handshake back and forth between all of these different management entities. There was a question in the back. Yeah. Yeah. That's, yes. That's a really good question. Are you a user right now? No, you're right. That was, if I had to pin 1 or 2 larger technical challenges to solve, in any dynamic infrastructure, which is really what this is, that is one of the biggest challenges to solve, which is how do you propagate resource usage-related constraints up the stack all the way into vCenter. And a lot of that work has been done. What I would suggest is instead of doing it here, we've got Srijit right up here. If you don't mind, as we pack up now, just come on out here. And these are the guys who made it happen. And you're right, there are checks and balances in the system to help you ensure nothing gets over-provisioned. And as VMs move across, they do the appropriate checks and so on. But I know all the technical details. I just don't want to tell them right now. I don't know. These guys know. Okay, I'm gonna wrap up. Really, thank you for your time. And have a great VMworld.